In this video, we're going to start talking about linearization and linear approximations. Definition 3.4.3. If f of xy has partial derivatives that exist and are continuous at ab, then the linearization of f at ab is the function L of xy is equal to f of ab plus f sub x of ab times x minus a plus f sub y of ab times y minus b. In general, if f is a function of n variables and it has all partial derivatives that exist and are continuous at a point a1 through an, then the linearization of f at a1 through an is the function L of x1 through xn, which is f of a1 through an plus the first partial, f sub x1 of a1 through an times x1 minus a1 plus all the way up to the partial with respect to the last variable, f sub xn of a1 through an times xn minus an. And if you had noticed in the first case, f of ab plus f sub x of ab x minus a, f sub y of ab y minus b, in this case of the function of two variables, this function is just the equation of the tangent plane. Using this as an approximation. The idea in this situation is that we can use the linearization of a differentiable function at a point P to approximate the function value at points in the domain that are close to P. This is completely analogous to what you may have done in your first calculus course, a tangent line approximation. And what you would have done there, you would have taken a point P, which was the point where x is equal to a, and you would have taken your function f of x. You would have drawn or calculated the tangent line at P. Let's move this over a little bit. And this is your point A. You would have said in the area around A, the graph of the tangent line is very close to the graph of the function. So if you had moved over a small distance dx, and you were looking to evaluate at some point A plus dx, well, the idea here was that the value on the tangent line, so let's call that L of x, is very, very close to the value on the function if you are close to A. In other words, what we're saying here is that L of A plus dx is approximately f of A plus dx. That those two values, the L and the f value at a plus dx, are very, very close together. In fact, in a function of two variables, what we call the tangent line approximation for a function of one variable, the linear approximation is often called the tangent plane, a tangent plane approximation, because just as we did here with the tangent line, it amounts to evaluating the point P in the tangent plane. In the next video, we'll do an example of an approximation using the linearization of a function.